is Christian Idealism, and today we are going to be looking into physics and its relation to free will. This is brought to you by Cal Allender. So first, why is physics important in our understanding of the nature of choices? And so, first of all, physics is how the natural world operates, and it helps us to understand our understanding of the universe. Cause and effect happen everywhere, and so we need to figure out whether we are the first cause in a chain of events, or if our choices are merely just part of the cause and effect that we have no control over. So, first off, libertarian free will does not deny causality, and it does not deny that things are determined. It just requires that it is determined by the choices of agents. In a world with free will, instead of having one type of cause and effect, you actually have two different types. So the first, of course, would be event causation, which is when physical objects cause other physical objects to move and have effects. No one denies this type of causality. However, in a world with free will, there is a second type of causality, which is agent causation. This is where someone's conscious choice was not determined by prior causes, and the agent/mind is the first cause in a future chain of events. This is where determinists and libertarians disagree on the nature of choices. And so basically, a determinist would say only event causation exists, whereas a libertarian would say, or someone that believes in free will would say, there's both event causation and agent causation in the universe. So, what does physics actually tell us about the nature of causality? So first, we need to distinguish between classical physics and quantum physics. So first, classical physics is about our Newtonian world in which all events have prior causes, and this is the part of physics we all interact with on a daily basis. This happens on the macro scale, in which things like our brain are present. In the next video, we will be looking into whether our brain actually follows Newtonian causality, or some other form of it, because, you know, if our brains do follow Newtonian causality, then we probably don't have free will. But if it follows some other different type of causality, then there's probably little room. So again, that's for the next video. But first of all, before we get to that, we need to discuss what's called quantum physics. And quantum physics is about the smallest particles in nature that we cannot see with the naked eye. To put it simply, the quantum world is anything smaller than the atom. This world follows Heisenberg's uncertainty principle and is thus indeterministic at the bottom level. This isn't to say that it had no prior cause, but rather that one cannot predict an outcome prior to an event like we can in classical physics. So it seems like this area of physics leaves a little room for free will, and in fact, it does leave room for free will. So I need to talk about what's called the strong free will theorem. This was developed by physicists John Conway and Simon Cochin, and this is called the free will theorem, and it kind of explains some of the indeterminacy in a quantum system. And it asserts, and this is from the paper, it says, quote, "It asserts roughly that if indeed we humans have free will, then elementary particles already have their own small share in this valuable commodity." So we have, more precisely, if the experimenter can freely choose the directions in which to orient his apparatus in a certain measurement, then the particle's response is not determined by the entire previous history of the universe. So what they're basically saying here is, if humans do have free will, then elementary particles should not be 100% predictable, or in other words, it should not be determined by the entire previous history of the universe. That's what they're basically saying here. And so I'm going to have the little explanation for this. So to understand the theorem, we need to know what it is saying. In orthodox quantum physics, particles are in a state of superposition prior to collapse. This is to say that before particles are measured, it does not exist in space-time as an actual particle, but rather exists in the form of a wave function. And a wave function, of course, is not in space-time. So, with that in mind, we need to also take into account Hilbert space and all the other stuff, but that's for a future video. So, if we take orthodox quantum mechanics as the most accurate description of reality, then prior to collapse there is no particles, and perhaps nothing can cause collapse if all is in a superposition. But I would say that our minds can, in a pre-collapse state of particles, would be the mind thinking about an outcome. To put it more simply, it would mean that the agent's first cause would be the particles collapsing into a definite position to create a chain of events that initially started with the agent's choice. This is how free will works as it relates to orthodox quantum physics. So the free will theorem would actually explain how particles behave when it is going through this chain of events that was started by the agent's choice. And so first of all, I need to answer some objections because, again, there are a lot of objections. I'm just going to answer probably the 3 biggest ones that have the most weight. So probably the biggest objection I hear is that this assumes that no hidden variables in quantum mechanics exist. And that is true. It does assume that no hidden variables exist. In hidden variable theories, it's, you would have determinism. However, I need to point this out. Hidden variables would have to be non-local due to entanglement in Bell's theorem. And if that's the case, then hidden variables can only exist if they remain in a state that goes faster than the speed of light. Now again, if they're going faster than the speed of light, it would be a violation of special relativity. So while it's true that we have never falsified all hidden variables theories, hidden variables would make quantum physics deterministic rather than probabilistic. And given the arguments in my last video, it seems like determinism in this case would have to have a higher burden of proof. And so, again, there is no reason to assume that hidden variables exist unless one has emotional philosophical reasons to think they do, which is not how science should operate. So the second objection is that this assumes that many worlds interpretation is wrong, since there you would have particles collapse into definite positions, but they are just in different universes. So then our minds wouldn't have any, it would just be passive observers, and minds basically wouldn't have the free will to choose what particles do. However, it doesn't assume many worlds is wrong, but rather that a deterministic version of the many worlds is wrong. I want to point this out because a lot of people have big, huge misconceptions. So, many worlds can simply fall into what's called the many minds interpretation, where you're allowed to have free will involved with particles. However, many worlds cannot explain the Bohr rule, since that makes some worlds more probable than others. But again, if we're talking determinism, then they should all have equal probability, but we know it doesn't because of the Bohr rule. And so the many worlds interpretation is actually more probable with free will than without it. And so while this objection does carry some weight to it, it carries very little weight just because of the fact that free will, many worlds would actually be it would make more sense to say that we have free will if many worlds is true rather than we don't, because of the Bohr rule. So now we have objection 3, which is, again, if quantum mechanics is random, then our actions are just caused by random events. However, determinacy in quantum mechanics is not about randomness, but rather it's about not being able to know an outcome prior to measurement. The libertarian free will argument from quantum mechanics does not say that since everything is not totally predictable, then we have free will, but rather it says that particles act in a way we would expect if free will exists, and if conscious observers have a role in wave function collapse. And I also want to point out that decoherence does not explain collapse due to the fact that I don't know why that says articles, but anyways, particles in the universe are in a superposition prior to collapse. But of course, this has to throw out the many worlds interpretation and hidden variable theories, but we already addressed that in our last response to the other objections, so I don't need to repeat myself here. So now let's kind of weigh the evidence for this. So far, we looked into physics and have shown that there is a second type of causality in the universe known as agent causation. When one accepts the basic facts of quantum physics without adding additional assumptions like hidden variables or many worlds, then it's most likely the case that conscious observers have free will to cause events in the universe without prior causes to them initially choosing those events. So with these facts of quantum physics, then it's most likely the case that humans have free will given this evidence from quantum physics. Again, this is assuming that hidden variables don't exist and that a deterministic version of the many worlds is wrong, but again, we already kind of addressed that before. So again, I'm not going to repeat myself on that. So I need to highlight an important consideration here. So first of all, this argument does assume idealism, the metaphysics of idealism, and it does reject physical realism in the sense that mind is the first cause in the mental universe. And so under idealism, all is mind. Under physical realism, you would have this world that exists independently of the mind. So yes, this kind of evidence for free will would in fact be incompatible with the ontology of materialism. However, in the next video, we will be looking into neuroscience and argue that even if this argument from quantum mechanics is wrong, free will is still the best explanation given recent developments in neuroscience and how the brain works for decision making. And so again, even if my argument in this video doesn't work, there are further arguments in the next video I'm going to go over that do show that free will is still the most probable explanation. So that will be my video. Thank you for watching. Like, share, and subscribe. And I hope to see you in the next video.